Hello everyone, I am Mugdha. On behalf of Dr. Dhawan Academy of Geologists, I welcome you all to the fourth edition of the DDAG Chat Show. In the past 2 years, DDAG has conducted 3 chat shows on interesting topics like Delhi earthquake, Atal Tunnel and Rishiganga flash floods. Today in this fourth chat show, we are going to talk about Mangdechhu, a 720 megawatt hydroelectric project in Bhutan that was commissioned in 2019. Today we have with us expert engineers and geologists who have contributed in execution of this project. Mr. A K Mishra, MD MHPA, Mr. Balraj Joshi, formerly CMD NHPC, Mr. Imran Sayeed, formerly Chief General Manager NHPC, Dr. Gopal Dhawan, formerly CMD MECL and ED NHPC, also founder and chairman DDAG. We also have Mr. Yogendra Deva from DDAG, formerly voluntarily retired director GSI. He is playing the anchor's role in today's talk show. On behalf of DDAG, I welcome all the experts and request Mr. Deva to please take the show further. Thank you.
Thank you, Mukta. Thank you very much. And to set the ball rolling straight away, I will invite Mishra ji and would like to know from him that we know that this is a mega project, joint project between Government of India and Bhutan. So what was the agreement like between these two countries and how these countries are benefited by this project? Mishra ji, please.
Thank you, Deva. I just would like to share with you that the Mangdechhu project came in existence after the bilateral agreement signed between the Government of India and the Royal Government of Bhutan on 30th April 2010. That point of time, the Foreign Minister of India, Mr. S.M. Krishna, and the then Ministry of Economic Affairs Minister Limpo Khandu from Bhutan side, they signed that agreement. After the signing of this agreement, the process for implementation of the project, Mangdechhu project, started. In this regard, it is also to be noted that the entire project layout, entire project's construction was to be planned in a way so that we consume the minimum time and for the overall construction of the project and do it as we have committed in the DPR. So therefore, my appointment to the project, I joined the project on 27th August 2010, and thereafter I started building up the team. And this team I could build in the faster manner. During this period of 1 year, which was given in the DPR, the 1 year was allotted for the development of the access roads and the colonies for the project, which I did. And we awarded the work of the major components like dam, HRT, underground powerhouse, electromechanical works by the 20th March 2012. And after this work, when the works were awarded, the contractors started mobilizing. If you look in that scenario, everything which we did in very first year was wonderful. And if you look at the layout point of view, I would like to share with you that the project is having the concrete dam along with the HRT. The dam is 114 meter high. Almost half of the height is above the riverbed, half of the depth is below the riverbed. Then 13.5 kilometer long tunnel. Then after that, there's a shear shaft. Then there is a pressure shaft, and then there is an underground powerhouse to this tunnel. This is the overall layout picture. Would you like to, Mr. Deva, ask me the next question?
Thank you very much. I think we have got the basic idea about the project here. And now I think I can turn to Imran ji. And because this is one of those mega projects in the Himalayas, the geology is very complex. So we would like to know from him, what was the geology like in context of the geotectonics of Bhutan, And what are the main challenges in carrying out the geological investigations like mapping, other investigations and other things? Mr. Imran, please.
Yeah, thank you very much, Deva Saab. The geology of Bhutan, unlike some of the Northwest Himalaya or Northeast Himalaya, so to say, as you can see in this map, the entire country is in a great Himalayan system, and the MCT and the MBT are quite close, excepting in the eastern region of the country. And then Trongsa is in the center of Bhutan almost. We have Thimphu Nisik complex covering wide area of the country. Then we have outliers here and there, and one of the outliers, which is near Trongsa, is called as the Cheka Formation. So this would make the geology a little bit complex. And then we also had the leucogranite in the project, which is a much younger igneous intrusion. It is only 30 to 10 million years old. And then the rugged terrain in the Himalayas. Added to it, as you have in the Northeast Himalaya, the Bhutan Himalaya also, the vegetation is very thick, as you can see in this picture. The outcrops are very, very scanty. This is the Mangdechhu River flowing about 5 kilometers downstream of Trongsa. And then you can see both the banks are the valley is quite narrow and it is full of vegetation cover. So obviously this is a challenge for the geologists to look for different rock types and then their engineering character, so to say. Added to this, the dam site, during the feasibility stage, several alternatives were explored. As many as 6 alternatives were looked for by the consultant at that time, and then they zeroed in on some axis. When NHPC came into the picture to prepare the DPR, we saw that site. They almost said that one of the sites had a canyon. The bedrock was 70 meters deep over there. Then they came a little bit upstream and then they selected that axis with about 60 meters of overburden, which was quite high for a 56-meter high dam. NHPC did a couple of drill holes here, and then there were some issues for the intake, or some certain overhangs on the left bank. NHPC thought it prudent to move the axis 500 meters upstream, and there NHPC took up a drilling and exploratory program over there, comprising of drill holes, drift, and geophysical surveys also. One of the drill holes in that dam site also had 57.4 meters of overburden, as I remember. But then even between the coffer dam, the dam axis, and the downstream coffer dam, there was a variation in depth of bedrock, substantial variation. If it was 50 meters at the upstream coffer dam, coming to downstream coffer dam, it became 70 meters or so. In the HRT, once again, we had a leucogranite huge outcrop near Thakse village, it is known, and that it was a challenge to how to project that outcrop at the tunnel grade. The regional dips were in the upstream of this outcrop, were in the southerly direction, and in the downstream of this outcrop, there was another formation, which is Cheka Formation. So gneiss on one side, mica schist and quartzite on another side, and in between the leucogranite. Then we had the shear shaft, which was There was no outcrop in this area. It was full of cultivated land, quite a huge amount of cutting, about 70 meters or so, which was handled in either in overburden or in weathered, highly weathered and decomposed schist rock, which was quite weak. Even the shear shaft, I will show you a section subsequently. Next, please. Even the shear shaft had a thick overburden as well as a thick weathered rock profile, so that we had to shift the shear shaft sufficiently inside the hill. But then this also had very hard intrusions. There you can see overburden, slumped and weathered rock and hard intrusives we had. So all this made it quite a complicated geological situation, which was handled by the stepped configuration of the pressure shaft. And then coming to the powerhouse, powerhouse was placed in quartzite, hard quartzite. Very little space over here for the porthead yard. Porthead yard excavation height was 120 meters, and with a careful excavation, with a well-designed support, this is one of the most attractive engineering achievement of the project, I should say, because when you have in quartzites valley dipping foliations dipping at a very adverse angle of 40 degrees, it makes situation very, very difficult. So this is one of the slopes which is a very deep cutting to create the space for porthead yard, which has been made without any collapse. So that way Mangdechhu had plenty of geological challenges which were handled by adequate provisions in design and then immaculate execution by the Mangdechhu Project Authority.
Thank you, Imran. Thank you very much. That was lovely. I will just ask you one question, that this HRT was about more than 13 kilometers long. So what was the worst underground excavation problem you experienced here in a very short?
Yeah, a very interesting question. In the downstream portion of HRT, as we saw in case of shear shaft, the rock was extremely weak, the mica schist, and then the entire land had entire area had a cultivated land on top. It was water charged also, so plenty of shear stuff over there. From one of the downstream faces, there was a substantial amount of poor rock. But one very interesting thing I would like to share with you here, I was looking at one of the papers written by A K Mishra, the MD who is with us, and he pointed out that almost 3.8 kilometers of rock was poor rock area. And when I saw the DPR, we estimated in the entire HRT 21% of class 4 and 5% of class 6, which is 26% of poor rock. And you know, 3.8 kilometers of 13.5 is 28% of poor rock. So overall, in overall assessment, we were not that far. But as I said, there were variations in couple of phases in which there was more poor rock. So,
thank you, Imranji.
Yeah.
Thank you very much. Good information. And looking at the geology, the remoteness of the project, and many other features here, we understand that there were quite a few innovations in the designing of the project, in the DPR and designing of the project. So now we invite Joshi ji and ask him to just enlighten us on these innovations in particular in the designing of this project. Joshi ji, please.
Thank you. Thank you. At the outset, I want to thank DDAG for giving this opportunity to us to bring back the memories associated with this wonderful project in Bhutan. Let me say that at the outset, when we were asked to design this project, the one thing which came to my mind was that this should be a thing of beauty, particularly the dam should be a thing of beauty. And I was particularly obsessed with the idea of having a small kink in the dam axis, because by virtue of my stay in Europe, I had seen many dams where they present a wonderful sight, because that the curve of the axis goes very well with the mountain curve also. So that's what you can say an infatuation with me. But ultimately it was required also as per the geological conditions, as we saw later. But the best part of this dam site was this was too narrow, and you would like to have a narrow valley for a dam because the dam length would be shorter. But here the added confusion was that the depth of the bedrock from where the dam is supposed to rise was about 50 meters below the riverbed. And excavation of that particular dam foundation you can see the constricted area between two cofferdams here. On the right side is diversion tunnel. So it was very challenging aspect for us how to lay down the road so that we can actually bring down the muck from there and dispose it outside on the downstream side. So that was a challenge. We had a small experience in NHPC for Teesta 5 project, but there the depth was about 45 meters. Here in some places we anticipated and also got about 55 meters. So I would say this is one innovation of design, where in the earlier times, people would not choose such a site if the depth of the overburden is so much. They will not place it, but we decided to do that. And then there are associated complexities which come in here. But I would say Mangdechhu afforded us many opportunities to NHPC. This was the first project of NHPC which was being done by NHPC on a consultancy basis, where they were not constructing it themselves. So we decided that we have to do everything so systematically that we present a real, let's say a start point for other dams to come henceforth. So all our knowledge and experience of NHPC was utilized for conceptualizing and designing this structure. And as you can see, as some photographs were shown in the beginning, it looked like a good structure and very nicely constructed by MHPA, I would say. And NHPC on its part also has been having separate meetings with the contractors to see that the surface finish comes nicely, the structure is laid very beautifully. And I'm sure I visited the project once in 2019 also again. And I was satisfied that reasonably we could do a good work. But coming back to the design part of it and the innovation which you have asked me, generally, this is a very standard design that you have a dam, you have two desilting chambers, a still flushing tunnel, and HRT taking off from there to intake structures. And this is very, mechanically seeming very mechanical kind of a design. But when you actually start doing it, let me introduce some complexities here. For example, the depth of the overburden becomes 55 meters. Then the diversion tunnel, which was designed for 800 QMX, suddenly you find that there was a storm called Ayla, by virtue of which the design flood had to be revised, whereby the cofferdam had to be raised slightly higher. And then we started excavating. A very beautiful thing happened, that in the intake area, we got a ledge. Can we really go to that slide of that ledge? Now, before that, let me just explain this longitudinal section of the reservoir. If you see this river, it's a very steep river, and the funnel is fixed by the physical and the geographical constraints which we have. And the MDDL is worked out, like what kind of peaking hours you want and you can be afforded, and minimum are 4 hours. So MDDL gets fixed. But the real crux comes, where do you place your intake and where do you place your crest of the spillway so that there's no sedimentation, because Mangdechhu Reservoir is a very small reservoir. And average slope you can see 1 in 15, so which is a very, very steep river. And this presented to us a lot of problems, as we shall see further. Next, please. And now placement of the intake. This was the first time in NHPC also, we have never done it earlier. But before deciding upon the intake level of the invert level of the intake, we actually carried out a sedimentation simulation, which is only a numerical modeling by Mike 11. And we decided upon the level of 1720 after running it for about 11 years. As you can see on the right side, there's a legend here. For 1 year, what was the profile? Second year, what is the profile? So finally, we found that at about 1720, this gets stabilized. So we decided this is the level going to be. And now we had to juggle between this particular level and the crest of the spillway, which was to be decided by the discharging capacity. And in between, one event happened wherein on the downstream side, there was a Gloff-like event which happened in Vachechu. that actually set the alarm bells ringing, and we decided we had to really think very hard. Should we raise our crest level of the spillway to afford good hydraulic conditions or not? So in the model studies at CWPRS, which we did, lot of permutations had actually been done, and CWPRS was saying that in the downstream side, the flow conditions are not very good, so you should try to raise the crest. But we said if we raise the crest, our intake is certainly going to get choked. So this was a tool which we used here, and fortunately 1720 level was decided, and fortunately now the project is performing very well. And I checked up with the MHPA later on also, sedimentation has not reached beyond those levels so far. Yes, please, next slide. Now this is the intake structure which was decided to be at 1720. And it was supposed to be excavated to riverbed level and then raised from there. However, we found a ledge, rock ledge here, and the issue was whether to place the intake here or not. But finally, considering the fact that 50,000 cubic meter of concrete could be saved, we said, okay, let us put it on the ledge only, and then we have to protect the ledge somehow. So this, when we excavated this area, we found that the rock at the intake toe was not quite competent. So we had to, give a special kind of cladding here with the long cable anchors to hold it in place. Next, please. Next, please. Yes. Now, this is one slide which I wanted to explain to you with reference to the longitudinal slope of the river. It is so steep that in the model you can see on the left figure, which says the free flow condition. As a discharge of 4,250 cumax, if you start opening the gates completely, what happens to the flow conditions at the intake area and the upstream of the pier noses, you can see. This was so ferocious flow that CWPRS was not able to decide upon the levels and how to hold this particular structure of intake which we have placed on the ledge in place. So that is why we decided to give a very thick cladding supported with the cable, very long cable anchors. And on the right side, you can see there are two small photographs here, which are taken from the model study only. When you have an orifice flow, which means you are doing a gated flow, in that case, you can see for the same discharge on the upstream conditions are very placid. And for the FRL conditions are very, very placid. You can see the lower photograph. However, this gave us another problem and challenge, because normally for Himalayan projects, you have a flushing system for sedimentation flushing. Now, if you open up all the gates for flushing, let's say on the left side, if you see the photograph, and you get such turbulent conditions near the intake, what will happen to the intake foundation? We were actually very, very scared because of this. So finally, after a number of meetings with CWPRS, number of permutations were made. And finally, we decided that for this particular dam, even though for Himalayan rivers, the flushing is a norm, but that cannot be actually used here like we are doing elsewhere. Otherwise, we will be risking the intake foundation. So therefore, a very elaborate kind of reservoir operation manual was evolved by us, which was issued to MHPA, and we have in bold letters we have written that this reservoir operation manual must not be compromised at any stage. Fortunately, the flood which has come so far is about 900 cumac only, and we are talking of 4,250. And some question could be raised why so high flood level had to be discharge had to be taken. That I can tell you that because of the Wachichu glove, which I call it a glove. I do not know, Imran Saab could have a better view of that, but I still consider that it was a glove because it brought in so much of debris that it raised the entire riverbed by about 13 meters. So that gave rise to another problem with us, because the Powerhouse central line was already fixed and with reference to the old bed level. And now suddenly you find the bed level has risen by 13 meters. So what happens to the central line? But fortunately, or I would say it was taken into consideration by us, considering the experience of previous projects, that we had slightly kept the central line of the machine at a slightly higher level, even though it cost us about 2.5 meters of head, but it proved very handy, and with the result that we had to raise the mat level also because the river had risen. So the mat level was raised, the TRT level was raised, but fortunately, since we were having that cushion available with us, so nothing happened with the efficiency of the machine, and that is working very well now, I'm told. So these are the innovations which are required to be done when you start designing and constructing a project. So in the paper design, when you sit on a table, everything is hunky-dory, but it's actually not so. Imran Sahib has talked about the step pressure shaft also. I can just confess here that about 11 meters of head loss was actually occurred because of the step kind of formation. And there were proposals earlier that it should be an inclined one, and like we had done for the Parvati project. But we were very sure, in discussion with Imran, we decided, no, we will have to do it in a step fashion because Geology was not supporting us. And that ultimately proved to be right also. So I think all these combinations together, along with the construction team at site, we could see that the project got fructified in good time and cost.
Thank you, Joshi. That was really exciting stuff. Really exciting stuff.
Thank you.
And now I think looking at the project, looking at so many complications, particularly in designing, because of the geological conditions, I think Dr. Dhawan here, he is having such a great experience in the Himalayas, and he has been associated with this project also very closely. So I would like to ask him that if we look at other problematic or complicated projects like, say, Parvati 2 at one hand, or Dulhasti at the other hand, and there are a number of other projects in India where geology has been really very complicated. So how would he rate this project from that standard? Dr. Dhawan, please.
Well, thank you very much, Deva sir, and good evening, everybody. You see, geologically, Mr. Imran Sayeed has very beautifully summed up the complications. With the help of the regional map, he also explained that here in Bhutan, in the central Bhutan, the width of lesser Himalayas is minimum because MBT and MCT are very close. And our project Mangdechhu, about which we are discussing, this is about 70 kilometers further north of MCT. This is a part of Greater Himalayan geology. Mostly, you can classify in central lines. And NHPC has constructed several projects in similar type of geology. You see, on a broader scale, when you compare, you may find that there are similarities and dissimilarities in the regional geological setup. But unfortunately, problems at every project are different. Any hydropower project is not a carbon copy of any other project. For example, if I tell you that we can compare some problem to problem, as Joshi ji also explained that over this river gorge had very deep overburden, and in higher Himalayas we have found this problem almost in most of the projects. I will compare Dholi Ganga. In Dholi Ganga, we had 70-meter thick pile of overburden, riverine sediments. As Mr. Joshi told that previously we could not think of a concrete dam with this kind of overburden thickness, and therefore in Dholi Ganga we went for this. We investigated in 80s and constructed in 90s. At that stage of time, we did not have courage to go for a concrete dam, although it was originally proposed by Swedish in the original DPR. So here now, with advancement of technology, with the availability of cut-off walls, because they provided a cut-off wall for controlling seepage under the upstream coffer dam. So this was a big challenge if we compare with other projects. And you see, no project in Himalayas is simple. Many times people think that because this project has been commissioned well in time, almost matching with the schedules, so this was a simple project. This is not so. Mangdechhu had its own, share of problems. Mr. Imran Sayeed has touched almost all the problems, so I will not go into detail of that. But I'll certainly say that construction of the HRT under 1 kilometer superincumbent cover was another challenge. And that too in the downstream portion of HRT, we had very weak rocks. As in other Himalayas, because of the topographical constraints, wherever we were to locate surface structures, it was quite challenging. Structures को locate करना आसान नहीं था. Be it your portals of edit portals or porthead yard or search shaft. He has shown you a slide where search shaft excavation is visible. A very steep cut had to be constructed, that too in very weak rock. Search shaft had to be pushed into the hill by about 12 meters or so. Powerhouse also had its own problems. So there were complexities, and these complexities were of equal, you can say, rating as far as other projects are concerned. But here I would say that with good geological investigation, with good coordination amongst the designers and the geologists, and very good supervision by the MHPA, really made this project looking relatively simpler than other projects. But geology was not friendly, I must say. Thank you.
Thank you very much, Dhamma. Thank you so much. And now I think we have looked at the planning and execution of the project here. So there are certainly our audience will be interested in knowing about some other aspects of the project, like the logistics, because it was a remotely located project. And besides that, what was the contract like and things like this. I've got a couple of questions more, and I will get back to Mishra ji to first answer these two questions, and after that we will go to the final stage.
Yeah, thank you, Devaji. Let us discuss the contract award options. At the beginning, I had three options with me, that whether I should go for World Bank document, whether I should go for the FEDIC based European based document, or I should go with the document which is already prevalent in NHPC at that point of time, because they were our consultant. And another option was, which was a little unique, was the adoption of SBD, that is standard bearing document, which was authored after a lot of efforts by CA, Central Electricity Authority, a lot of contributions made by NHPC and other senior officers of hydroelectric projects to develop the document. Unfortunately, at that point of time, that document was not implemented in India, but I understand at that point of time that the document was good. It was readers friendly document, and I thought at that point of time that let's go for that document. The advantage of the document is that this is written in a simple language, and a lot of things were taken care of, which I consider is basically the weaknesses of the other documents. For example, just for your consumption, that when you are paying the price adjustment to a contractor in a running bill, we are compensating him 100%. But in this document, 10% as considered as a theoretical component of the contractor's profit, and which was taken out. So 90% of gross value was adjusted for price, not the 100%. And if you look in a very rough manner, I completed my dam work, say at 970 crores. If you take that 10% difference, I would have paid more than 50 crores had I been compensating for all value more to the contractor. So that is the saving I derived. Similarly, the risk matrix we have introduced, that whether it is owners to the account of owner or to the account of the contractor, risk sharing was involved, and this has helped the Mangdechhu to decide and whether a particular event is falling into the contractor's purview or into the owner's purview. With respect to that, we could decide a lot of things without any litigation. So this matrix was introduced in our contract for the first time, and this has been experimented very well in the Mangdechhu, and a lot of litigation, a lot of arbitrations, a lot of claims were avoided. So this is the first advantage we got, and this document has been accepted very nicely within Bhutan. I'm sure in future also they will prefer to go by this document. This is the part of the contract as you asked me. Second part is the logistics. Yes, Mangdechhu is centrally located project in Bhutan, and you have to enter to reach my project. You have got two places to enter. That is, one is the Phunchling, and another is the Sandrup Jonker, the eastern side and the western side. The most of the route right from Phunchling to Wangdi is checked because a lot of equipment has traveled. But beyond Wangdi to Mangdechhu, there was no check, and you have to cross a lot of bridges. These bridges were never designed for that loading, which we are going to, load these bridges afterwards. And in this contest, I searched initially 2 years that how to utilize the expertise available outside Bhutan to ensure that we are not putting any bridge into danger. If any bridge fails, whole project will go. So what I did, I checked up with the Ministry of Road and Human Settlement in Bhutan that how many bridges are done by Swedish company, how many are done by the Japanese companies, because most of the bridges were done by them and donated to the Royal Government of Bhutan. So when I approached them, they asked me that you please give us the loading. So I provided them the axle loads, the rolling loads, how it is going to travel, what is the vehicle speed, and then they checked the bridges, all these bridges for the loading given by me, and then they suggested some corrections in the profile of the trailer. They have advised me at that point of time to add 2 axles or 3 axles, and the speed restrictions. With that, we moved, and in spite of knowing that these bridges are not designed for such heavy loading, because each empty transformer was weighing about 75 tons, prime mover load about 15 tons. So at a time you are crossing on a rolling mode something like 90 tons, 85 to 90 tons is a big risk, and most of them are steel bridges. So this logistic was a big challenge, and we did it scientifically. It was approved by the original designers, and loading was refined, tailor design was refined, and then we moved accordingly. So this is the answer for your question.
Thank you, sir. Thank you very much. And just very briefly, could you please say a few words about the cost of the project from the industry standards?
Yeah, see if you look at the Mangdechhu, the DPR was done at 2,896 crores, March 2008 price level, and we awarded the work in March 12. So there's a gap of 4 years, and when we completed the work, it was 2019. So if you update the price of the 2008 DPR price to the year of completion, there are 11 years gap. So even if you take theoretically, which I did recently, 3% price adjustment, 3% inflation per year, roughly it is 33%. So the price which you took in 2008 as 2,896, it becomes 3,600 approximately. And the completion cost, which we are finishing the project, or we have finished the project, is 5,110 crore. So the total rise with respect to DPR updated price is just 33%. And if you go into the overall, you will find that this project has been done in the optimum time. Why I'm telling optimum time? I awarded the work on 20th March 2012, and I completed the works by 20th March 2019. So in 7 years, we did the job. Entire project was made ready, in spite of having so many difficulties, as the Joshi ji has said, Dhawan Sahab has said, Imran Sayeed ji has said. In spite of all this, the project is done. The reason is that we have not lost time anywhere in decision making. I am after the designers that give me the decision, and we moved forward. We have never stopped the project. We have never stopped the work for the want of decision. No, never. So this is how the whole thing has been done. And if you look the chronological order, today if in this project we are generating the DPR says that it will generate 3 billion units in a year. And my tariff fixed with the two governments, government of Bhutan, government of India, 4 rupees 12 paisa per unit. And in 2.5 years, it is not even 2.5, it is 2 years, 4 months, we have generated revenue worth 29 billion. 29 billion.
That's great. That's great. Thank you, sir.
The cost of the project is 51 billion. If you keep on doing at this pace, another 1 year or 1.5 years, you will recover the entire cost. That means in 4 years, Mangdechhu will return back the entire cost. My per year earning is roughly 1300 billion. 1300 billion. In 2 years, as I'm telling you, 29 billion. That is in spite of having some problems with the unit. Otherwise, it would have been more. With respect to this heavy revenue flow to Bhutan, this pandemic, which started in the end of 2019, 20 and 21, Bhutan sustained the entire economy because of Mangdechhu. 40% support was given by Mangdechhu. And today also, if you look at in the lean season, Bhutan is looking for import of power from India because the Tala is under maintenance, the other projects are under maintenance. Only Mangdechhu is sustaining and continuously supplying the power to the eastern gate of the India and to the northern gate of India. So 14 states are getting supply from the Mangdechhu project. We have connected the line at Alipurdwar in West Bengal, and there's a dedicated line built by on the Indian side by Power Grid, and within Bhutan we constructed the line. This is 400 kV double corridor. Double corridor.
I can see that our DDAG host has emerged from a hiding, so maybe we have overshot from the time given to us. And I will take liberty, Mugdha, I will take this liberty of a couple of minutes and ask all our guests here, anybody who wants to share any memory he's carrying from this project. Joshi Saab, would you like to say something?
There are so many, Deva Saab, that it will take 1 hour to actually start reading. So, but yes. I will just briefly tell you during DPR, as I also explained for my longitudinal section of the river, that this is a very steep river and the flow is almost like shooting. It's a supercritical flow in the river in the nascent stage itself. So it takes some kind of guts actually to stand at the shore of the river also. So during DPR, for going across, we had put a small makeshift kind of a bridge with the nylon ropes. And there was one photograph in this chart show also where one machine is standing in the center to drill the hole. And from there you can see that bridge also actually has been lodged. So now if you stand on that bridge and you want to go to the other bank, and by any chance if you start looking down to the river, the flow is so shooting that you imagine that as if you are stationary and the river is stationary and you are moving along with the flow. So it took some guts actually to cross over to the river, to the other side. And I remember one of our executives actually had to be bodily lifted from there because he was not having guts to cross the river from there. And there are so many anecdotes, the snakes being entering into the tents of people who were residing by the river for drilling. And there was a, beer, I mean, the black kind of Himalayan beer roaming in that area where we were supposed to go and do our surveys. So, and the Bhutanese very clear, very innocently told me, I said, what is this sound coming from? He says, no, sir, wo balu hai. There's a beer there. So very, sweet memories of the project. And I'm very glad that it has come out nicely and we are today talking about it. Thank you very much.
Thank you, sir. Thank you very much. Mugdha, I hand it over to you now. And I think I've not done my job properly today. We have overshot, I think, quite a few minutes. But anyway, I close it here, and the show is yours now.
Thank you. Thank you so much, sir. The topic is so interesting and the speakers are so experts in their respective fields that it was obvious that, there was so much to hear from them and they had so many experiences to share with the audience. But anyway, on behalf of DDAG, I thank all the experts for sparing their valuable time and experiences with us. And DDAG will be coming up with more such chat shows in future about further, more interesting topics in the field of engineering geology. and suggestions from viewers are always welcome. You can watch this chat show as well as the previous ones on our YouTube channel, that is the YouTube channel of Dhawan Academy. And you can also keep checking our website, that is dhawanacademy.com, for updates on our future on our future programs. So thank you for watching and take care. That was all for today. Namaste.
Thank you.
Namaste.
Thank you very much.
Thank you very much.
Thank you.